Hi, everybody. It's Miss Rose. This video is meant to provide you the support that you need on solving problems involving area with special right triangles. So let's take a look at the first one. I see a 60-degree angle. So I know that this triangle here is a 30, 60, 90 triangle. So let's use the patterns that we've practiced. And if the hypotenuse is 10, that means that the short leg must be 5 and the long leg must be 5 root 3. Do you know the base of your parallelogram? Do you know the height of your parallelogram? The answer to both of those questions should be yes. So pause this video for a second and see if you can find the area of the parallelogram. All right, what we're going to do is we're going to use a base of 20 and a height of 5 root 3 and just do a quick base times height to get an area of 100 root 3 square units. Let's move on to question number 2, which involves drawing a picture. We have to draw an isosceles trapezoid. The upper base is 12, and the legs are 14 root 2. It's isosceles, so I put a 14 root 2 by both legs. The lower base angle is 45, so that actually means both lower base angles are 45 degrees because it's isosceles. So I'm going to draw in a height. And it's not exactly drawn to scale, but do you see my 45, 45, 90 triangle? Take a second and pause the video and see if you can find the lengths of the legs of that 45, 45, 90 triangle. Okay, if the hypotenuse is 14 root 2, then the legs should be 14 and 14. Let me also draw this one in. All right, pause the video again and see if you can find the base of the isosceles trapezoid. Okay, I'm going to drop this 12 down. And when I add up 14, 14, and 12, that will give me the length of the entire base of the isosceles trapezoid, which has a length of 40. So there's a few different ways to find the area of a trapezoid, but let's use the formula that we learned, which is mid-segment times height. To find the mid-segment, we need to average the two bases. So I'm going to add up 12 and 40 and divide by 2. Try that and see what you get. It should be 52 divided by 2 is 26. And then to find the area of the trapezoid, we'll take that 26 and multiply it by the height of the trapezoid. Which number is the height? It should be 14. And let me grab my calculator to do 26 times 14, and that's an area of 364 square units. All right, one more problem to do. We have a hexagon inscribed in a circle. And it doesn't look like there's any special triangles here, but remember that hexagons always get split up into 6 equilateral triangles as long as it's a regular hexagon. So it says the circumference of the circle is 24 pi. So I'm going to use the strategy that we practiced in class and put in 24 pi for the circumference. So 24 is the diameter. So 12 is the radius. And then radius squared pi. 12 squared is 144. So the area of the circle is 144 pi. Well, where do the special triangles come in? First off, there aren't any numbers in the picture, but I know that the radius of the circle is 12. So I can put that radius here, or I could put it here. And then since it's an equilateral triangle that I formed in that hexagon, this is also 12, but I'm going to split it up into 6 and 6. And half of that equilateral triangle is a 30, 60, 90 triangle. So take a second and pause the video and see if you can find the height of the triangle, which is also called the apothem of the regular hexagon. Okay, if you use the pattern that we learned about 30, 60, 90 triangles, you should get 6 root 3. So what I'm going to do to find the area of the hexagon is I'm going to find the area of one triangle. It has a base of 12 and a height of 6 root 3. And then since it's a triangle, I have to divide by 2. And then, of course, the hexagon is 6 of those put together. So I need to multiply my 36 root 3 times 6. The final question is, what is the area of the shaded region? So if you notice, there's a circle and then the hexagon is taken out of it. So figure out what your strategy is going to be to calculate the area of the shaded region. Pause the video and try it. And then when you're finished, you can click back on the video to check your answer. All right, the area of the shaded region should be the area of the circle minus the area of the hexagon. So if we want to keep just an exact answer for our solution, the area of the circle is 144 pi, and the area of the hexagon is 216 root 3. If you want to, you can type that into your calculator and get a decimal answer, but I'm perfectly happy with that acceptable exact answer. Let us know if you have any questions.